Welcome back to Steel City Drones. I want to show you some of the stuff that we've been really working hard in the past few months on. Is an online mapping course that everybody has been asking for. We have a really good course coming out very soon, and I want to show you one of the things that we're including in our course right here is an accident reconstruction situation where public safety had to do reconstruction, and we are creating a 2D map as well as a 3D map. There's a lot of people that don't understand how to be able to create really good 3D maps in more of a complicated kind of space and point of interest like this. We've seen a few different public safety agencies come to us out there and ask us for help because they were getting really below the lines type of results. So in the situation where for this exercise we're doing, we have a base setup here. We have ground control targets that we put out as well. And we are flying this mission with the Mavic 3 Enterprise. It's smaller, so that we'll be able to fit this in through smaller type of obstacles and maneuver around things a lot easier than, say, a Matrice 300 or 350. The Matrice 300 and 350 will also only do this with the H20, H20T thermals as of right now, at the time of we're doing this, H30T possibly as well, but we cannot use the P1 camera for the orbits. At least we cannot do the automated orbits that we're going to do in this exercise with that camera. So, also, the Mavic 3 Enterprise has the ability, with its mechanical shutter, which is very important, that we can go ahead and set the self-timer for the orbits to 0.7 seconds. So every 0.7 of a second, it's going to take a picture. So we're going to help us get enough data to be able to do this. What we have is we brought these cars in. It's actually pretty cool how they brought them in. They created some skid marks down here to simulate a full-size accident. So what we're going to do is we're going to go ahead, set this all up. We have our base station up there for our RS2 Plus. We have that set up and got that on a known point. Then we set 3 targets down. And then we set them up on the rover, got and acquired all of those recordings as well. And we also have a 1x5 strip here that we're also going to be able to use that and just to double check measurements. We're going to shoot it with RTK and without RTK, just with the normal consumer grade GPS system. And then we're going to take our measurements on our skid marks and compare that data both ways to see if the measurements have any change, whether we add RTK or not. And we're going to now show you some of the results that we have. So when we came back to the office, we took all of our checkpoints and observations that the GNSS receivers brought in, and we brought it into a program called MWOOD Flow 360, which is a pretty cool program where it allows us to be able to plot our collection of data, and then we can actually get all of the data that it collects. Then we can export all this out to a spreadsheet. So right here on the spreadsheet, the base station that I set up collected this data right here. This is the local state coordinates, and then this is the global coordinates. And then what we did was, as a backup plan, we actually took raw Rhinex data the entire time that we were there. And then we were able to bring that into a third-party software processing called Opus. And that's kind of like the standardization for post-processing survey data. This report gives us the corrected data from that point that it takes, and then gives us basically these coordinates right here. So I was able to actually compare the 2 points, and the actual RTK versus the post-processing data actually comes out very close. So our X and Y and our elevation is very tight, and then we were able to use this as our benchmark to be able to process our data. So I've brought the data set in of the non-RTK mission first into DJI Terra. So you can see this is the straight down passes as well as the oblique, along with some orbit passes that we have here. And if I turn on the satellite view, you can see how that blends in with the Google Maps view as well. So what I'll do is go back out of here and I'll start zooming in. I'm going to turn off the cameras. So this is our Hoodman scaling tool that we have. It's exactly 5 feet long. So I measured the distance as best I could right here and try to interpolate these pixels as best I can. And then I have a very straight line that's very parallel to the roller. And you can see that's at 5 feet. And the measured distance right here is 504. So that's a lot less than 1 centimeter of accuracy. Now, again, this is relative accuracy that we're talking about. Again, so to put this into perspective, this is the non-RTK flight that we did. So it's only geo-referencing the flight with the internal GPS system that can have an absolute accuracy error of between 3 to 20 feet. But you can see the relative accuracy here is very, very good. Let's go to the 3D model. So you can see that we have our orbits right here. I'm going to turn off the cameras for a second. And let's go ahead and take a look at the definition of these cars. Again, this is a little wet outside, so you can see the actual water that's on the bumper that wasn't cleaned off. You can actually see again that the car is wet from rain. You can see how well the rust comes in on the roof. And we're even getting some of the interior data pretty good. The condition of that front bumper, you can see the word Toyota. You can see the bend in the hood of this Buick. Scratch marks. Again, all very uniform and scaled properly. You can see the water from the rain on this car. And again, we can even see some of the interior on this vehicle, which is outstanding. So we're going to put the cameras back on. And you can see we have a total of 3 orbits here, as well as what we call a staircase as far as a series of pictures go. So we have the traditional 2D passes as far as the nadir position, as well as oblique pictures here. We also have these orbits around here that this technique overall works very, very well. Now, we're going to go ahead and show you another project. And this is a pass that the local police department did by themselves. And they also did something very similar to what we did. And they also tried their own orbits as well. Let's take a look at how theirs came out. I'm going to turn off these cameras. So as you can see, we have some pretty good distortion with this Buick right here in the upper part of it. And a lot of that is missing on this red car as well. The backside here is not that great. So this is what we're seeing with some public safety agencies struggling with to try to be able to get a good reconstruction on 3D models. So what we're teaching in our class is exactly the techniques that are needed to be able to get very good and consistent 3D representations on here. So let's go ahead and measure the skid marks. The one on the left seems a little longer. So it starts about right here. And from that to the back of the car is right around there. And the straight distance on those skid marks is 30.81 feet. And we can take that to the bank since we know that our survey reference length is absolutely correct. So now that we got this data set, let's go ahead and look at the data set with RTK, and let's look at absolute accuracy that we did with our checkpoints, and we brought that data set into Pix4D to compare. All right, so this is the quality report from Pix4D for this data set. This is the RTK data set that we brought in. And let's scroll down to what we're looking for as far as the accuracy goes. So these are the 3 checkpoints that we brought in. They say GCP, that's just the way they're labeled. If they were using the GCPs for the accuracy as part of the reconstruction, you would see it here. So for X, Y, and Z, our errors are all inside of 1/10 of a foot. On the Y, we have no more than basically 5/100ths. And on a Z, no more than 7/100ths. So all within 1/10 of a foot. So the highest value at just about 7/100ths is 0.17 centimeters of accuracy. So the absolute accuracy is extremely good. The last thing we want to do in Pix4D is measure that same reference strip. So what I did was I created 2 manual tie points and measured the distance between them on the very ends, just like it did with the other software. And here, this measures at 5.02 feet. So again, I think that, if we're getting get down to the really nitty gritty, the RTK data set with the better absolute accuracy is approximately 2/100ths of a foot tighter for the distance. So to conclude, the results are extremely similar. We only have a difference of 2/100ths of 1 foot on that measurement. So the absolute accuracy does bring it in ever so slightly better. However, they are both very good. Overall, it's really important to be able to have absolute accuracy as just as a backup plan, fall safe if you ever have to be able to validate your data. All right, so I hope you enjoyed this. That's just a little bit part of the actual exercise that's in the course. And if you have any questions, please feel free to give us a call. Let us answer any questions that you may have. We're anticipating that our course is going to be done just right after the first of the year. So stay tuned for that. Thanks again for watching, guys. We'll talk to you soon.